Hi, this is Dr. Eddie Morgan over at Clovis East High School. Let's get started with our homework help tonight. This is for Math 1, Worksheet 4.1b. Remember, every problem on the homework help mirrors a problem on your homework, so you can take a look at each problem that you're having trouble with, fast forward to that, and get an idea here. Problem 1 says you're looking for an after-school job. One job simply pays $7 per hour. Another pays $10 per hour, but you have to buy a uniform that costs $36. When you're working problems, particularly linear problems, and you see something like this, which is dollars per hour, that should remind you of a slope or a rate, and that's exactly what it is. So let's start by I'm going to let y equal my earnings, how much money I earn, and x is going to equal the number of hours I work. Okay. So at my first job, y equals, I make $7 per hour. That's it. 7 times the number of hours gives me that. Second job, in this case, y is going to equal, I make $10 an hour, but this time I have to buy a uniform which costs $36, and they're going to deduct it out of my payroll. So it's 10 hours minus 36. Okay? So let's graph this and see if we can get it. It's going to be kind of tough. The first one, notice it doesn't have any y-intercept because it starts at 0. All right? Now I have to look at my graph and see where am I going to place this. And one thing I notice is I'm looking for something that would go into 7. And you notice nothing goes into 7, but I do notice here 105. Let's see, 105 divided by 7. 35, 15. So this is going to be, there is going to be the point 15, 105. So if I come out here to 15, right here, and come up here to 105, and so now I can draw my line between those 2 points. And that's my first job. All right. Now the second one, a little more difficult. We didn't leave enough room here. Notice if I were to extend my line down here, that's 30. 36 is almost way down here. So now I want to find some points up here that match as well. For example, if I put in x equals 4, if I put in 4, y equals 10 times 4 minus 36, that's going to be 40 minus 36, or 4. So this would be 4 and about right here. Let's try another one. Let's try something like, let's try 8. Y equals 10 times 8 minus 36 is going to be 80 minus 36, which is going to be 44. So at 8, we're going to come up here almost to 45. Okay, let's try 12. 10 times 12 minus 36 is going to be 120 minus 36. So that's going to be 84. 1284. That gets us pretty close. Maybe the point, or maybe close to the point. Whatever it is, let's just draw a line from here to here. Okay. So here's a point, 1284. Now, from our rough drawing, that looks like it works. However, we need to check it out to make sure it works. It works in this one, but let's try it in the other one. What is 7 times 12? Well, 7 times 12 is 84. So this is our answer, 1284. That is the place where the two come together. So if I want to find them, that's how I answer this question. How will graphing help you? It helps me find that point. So at first, when he's working, he would make more money working the first job up in for the first 12 hours. After that, the other job kicks in because then you've paid off your uniform and you're making more money. All right? Okay, let's move to the next problem. Problem 2 is an error analysis problem. It says that a student graphs the system y equals minus x plus 3. Notice that's going to be this one right here at 0.3 going down negative 1. And then also y equals minus 2x minus 1. Notice that y-intercept is here and going down by minus 2. And he concludes that there's no solution because he doesn't see them cross. However, the reality is he's not looking at what would happen if you extended it off. So if I take this red one and extend it out here, and I take the blue one and extend it out here, it is going to cross someplace. And if we actually were able with a graph paper, we would see that it would actually cross at the point minus 4, 7. So the answer of this would be the student didn't show enough of the graph. Okay. So that was his error. If you continued out, you would if you continue the graph, the lines will intersect. Which implies there is one solution. Problem 3 says, suppose you graph a system of linear equations and the intersection appears to be 2, 9. Can you be sure that the ordered pair 2, 9 is a solution? What must you do to be sure? Well, this is one of the problems with graphing. You know, you're graphing here and you have the point 1, 2, up 9, and it looks like it. You're looking and going, yeah, it looks like it, but you're not absolutely sure. Well, the way you do this is, can you be sure? Well, yes, you can be sure. But the way you have to be sure is you substitute the point 2, 9 into each equation. And if each equation results in an identity, in other words, you end up with something like 2 equals 2 or 5 equals 5, then 2, 9 is the solution. In other words, 2, 9 has to be a solution of each point. That's what you're looking at. So you can figure this out by plugging the numbers into each equation, making sure they solve that equation. Problem 4 has to do with cell phones. A cell phone provider offers a plan that costs $35 per month. See that per month again? That tells me that's probably going to be my slope, plus $30 per text message sent or received. A comparable plan offers $50 per month, but offers unlimited text plan. Okay, so let's let, for example, I'm going to let y equal the cost for the month, and I'm going to let x equal the number of texts. Okay, so the first plan, we'll call that plan A. For plan A, it's going to cost you $35 plus 30 cents times each x. Okay, or if you want to turn that around and put it in the y slope, that would be y equals 0.30x plus $35. Notice this is 30 cents. Now plan B, on the other hand, it is simply going to equal $50 a month. notice there's no x at all. All right. So on the first one, notice that my y-intercept here is 35, so we come up here to 35, and then it's going to go up 30 cents for every x. All right. So let's pick a point, for example. We need to pick a certain point. Let's try to get it into whole dollars. Well, so if I let it be 10, let me let it be 10's too small. Let's get out here, and we want something nice that will. Let's let it be 60. So 0.30 times 60 plus 35 is going to equal I get 0, 0, 3 times 6, 18. That's going to be $18 plus 35, which is going to be $53. Okay, so if I come out 60, this is going to be out here at about $53. So here is our graph. On the other hand, the other one, y equals 50, that's just a horizontal line right here. So it looks like our graph is right about here someplace. So we may just have to kind of figure around to figure out what it is. And so we noticed that 60 was a little bit over. So let's drop it down. Let's drop down to 50. So for example, if I say 50, y equals 0.30 times 50 plus 35. And then 0.30 times 50 is going to be 0.015. So that's 15 plus 35. And that actually equals 50. So that's our answer, 45, 50, 50. And so that actually equals our point. And so our answer there is 50-50. All right. I got lucky and picked 50. I might have had to try another one like 51 or 52 to find where I actually got what x is going to give me 50 here. You know, one other way to do that would have just simply put in 50. And if I solve for x, that would end up leading me to find out x is 50. Okay, but we're doing this by graphing. Now, next question says, if you send or receive $45 text message each month, which plan would you choose? Well, 45 is here. So notice 45 would be here. If you're looking for the cheapest, remember that this was plan A, and this was plan B. So if you only make 45, it makes sense that you would use plan A is the cheapest. On the other hand, notice if you do more than 45, more than 50, up in this area, for example, like let's say you do 105, this one then, this would be the cheapest. So if you're less than 50 minutes, you're going to want to use plan A. If you do more than 50 minutes as text messages, then you want to do with plan B. The next four problems ask you to look at the equation and without graphing decide whether it has one solution, infinitely solutions, or no solution. A lot of this has to do with the slope again. So if you look at the first equation, I notice that the slope is 1 and my y-intercept is -5. The other equation also has a slope of 1, but its y-intercept is different. So when we have the same slopes and different intercepts, that implies parallel. Parallel lines will never intercept, so our answer here is no solution. Problem 6, again, we're trying to decide whether it has one solution, infinitely many solutions, or no solution. Again, we need to compare them and check and look at their slope. That will help us the most. So first thing, let's get these into the slope-intercept form. So here's my first equation, and I want to put this in the slope equation form. So first thing I'm going to do is add y to both sides, and I get x equals y minus 1/3. So now let's add 1/3 to both sides, and I get x plus 1/3 equals y, or conversely, turn that around, y equals x plus 1/3. Notice my slope is 1, my y-intercept is 1/3. Okay, let's take a look at the second equation. 3x minus 3y equals -1. Let's move the y to the other side. 3y minus 1. And now let's undo this, plus 1. So I get 3x plus 1 equals 3y. Let me flip it around right now, or 3y equals 3x plus 1. And now undo the 3 by dividing everything by 3. And now I get y equals x plus 1/3. Notice the slope here is 1, and the y-intercept is 1/3. Now if you look closely, you'll notice these are exactly the same equation. Once we got them solved, they were the same equation. Okay? So they're not parallel, they are the same equation. Which means if you're graphing them, one will graph like this, and the other one will graph right on top of it. So how many solutions are there? Every solution in the red line is also in the blue line. So the answer is infinitely many solutions. Once again, problem 7, we're trying to figure out if this has one solution, infinitely many solutions, or no solutions. So let's put them both into the slope-intercept form and compare them. The first one's already in that form, 4x minus 1. So notice my slope is 4, and my y-intercept is minus 1. Now let's take the second one, take a look at it. So first of the thing, I want the y on the other side, so I'm just going to turn the whole equation around. Okay, 2y plus 2 equals 8x. Now let's subtract the 2 from this side, both sides. And I have 2y equals 8x minus 2. And now we'll divide by 2. And we end up with y equals 4x minus 1. Notice again here, this equation and this equation are the same. So we have the same equation, which means, again, one line is just on top of the other line. So that means I have infinitely many solutions. All right, our last equation. Again, we're trying to find if there's one solution, infinite solutions, or no solutions. So let's write them all in the slope-intercept and see what we get. So first off, 4x plus 3y equals 1. We want to get the y by itself, so let's subtract 4x from both sides. We have 3y equals minus 4x plus 1. And now we'll divide by 3. Everything gets divided by 3, all parts of it. So we end up with y equals minus 4/3 times x plus 1/3. Now don't get fraction brain freeze on me. Not a problem here yet. Let's try the other one. 3y equals 5x plus 2. Okay, so we'll divide again by 3. Everything. That gets rid of that. And we have y equals 5/3 x plus 2/3. Now notice here, the slope here is minus 4/3, and the slope here is 5/3. So they have different slopes. That means these two lines are going to intersect. So the answer here is there's going to be one solution. All right? I hope that helped you tonight. See you in class again.